14 years in the making already exists. And for 14 years, the Biomimicry Institute and the Biomimicry Guild have been introducing this world to the innovators and educators who will reimagine ours. But the one thing we've learned is that organisms never stop innovating. When their habitat conditions change, they adapt and they evolve.
During winter, the leaves fall off and only the stems remain. However, in summer, when the leaves are dense and fully matured, the vines protect the building against strong radiation and heat. When the sunlight hits the vines, they utilize all the energy for the photosynthesis process and filter most of the light that hits the facade. This is one of the main reasons why inhabitants refuse to cut off the vine that has covered the entire surface of the building. They reduce the heat gain through the exterior walls to a great extent, leaving only the building to the advantage of natural daylight rather than the radiation. A passive system that inhabitants can take advantage of is to have a consistent shading into the spaces. The dense arrangements of the plants breaks the direct sun rays, and as a result, the light emitted into the spaces are diffused and suitable for the purpose of offices, libraries, and museums. One could imagine a museum of botanical gardens that utilizes this technique to filter light for the interior. A common characteristic of plants in general is that they absorb carbon dioxide and produce oxygen. Building surfaces are the main absorbers of air pollutants, and over time, the face materials deteriorate and turn dark in color. For places with high levels of air pollution, such as Tehran, allowing the climber vines to grow and maintaining them is an advantage and a positive point for pollution reduction. Yet another passive strategy for helping the carbon dioxide levels in a polluted city to drop. Climber vines, when attached to a surface, absorb solar radiation for all the areas that are covered by the leaves. This is because the leaves grow in a manner that overlap one another, and therefore, when dense, the building is protected from direct solar radiation. As a natural process, the leaves take advantage of direct rays to enhance their growth. In Tehran, having low sky coverage for most days of the year, old buildings maintain the climber vines that has been growing on the facades for years as to cut down costs on insulation. Tehran is the capital and the largest city of Iran, where half the industry and production of Iran is based in. It is the industrial and political center as well, with a current population of 12,223,598 people, according to the statistics published in the year 2013. Geographically, Tehran is 1,200 meters above sea level, surrounded by mountains and valleys, with an area of 1,500 square kilometers, therefore keeping the air stagnant and polluted since there is not much of air that can circulate in the region. The big curve throughout the chart is an indication of the wide range of temperature readings for a year. The lowest recorded is -5 degrees Celsius in January, and in July it is recorded as 40 degrees Celsius as the highest. Because of the high level of carbon dioxide in the air, the temperature may seem hotter, whereas in reality it's more dense. On average, the mean percentage of sky coverage is 45 degrees. Every month has a similar high and low for the amount of sky coverage, therefore concluding the reason for stagnant and polluted air in Tehran. Wind velocity in Tehran is not very noticeable. However, in some days, there are unexpected strong winds. On average, the mean velocity is recorded as 2.8 meters per second, with a high of 16.5 meters per second and a low of 0 meters per second, which means no wind at all. The reason for relatively low wind velocity is mainly because of the dense urban fabric of the city. The project chosen is located in the center of Tehran in a public park. Tehran Museum of Contemporary Arts, the first building in the style of modern architecture in Iran, designed and constructed by architect Kamran Diba from 1967 to 1976. This project was programmed as a museum and a cultural center, which was all part of the intention that the architect had, that was to make an introduction of Western art available to Iranians. The building sits on the west end of the park and has its own separate entry. As seen, the building is oriented at a 45 degrees angle, which utilizes the sunlight for indoor lighting all day. The image above shows the entrance of the museum from the street. Behind these recessed glass doors is the main foyer, which consists of a bookshop and a circular ramp that connects all the stories from the middle shaft. The axonometric plan shows the gallery spaces, and the dark green indicates the circulation between these spaces. The project consists of multiple gallery spaces. However, for the sake of analysis, the foyer and one gallery was selected to evaluate the existing condition and compare it with the changes proposed. The walls of the museum complex is 40 centimeters thick and is constructed from concrete cast inside to give the sense of the West's brutalism approach for treating surfaces, and so were the roof. The glazing for all windows are single glazed 6 millimeters thick. The result of electricity consumption of only these two spaces throughout a year is 150,566 watts per hour. However, the proposal is to add insulation on the building surfaces to reduce heat gain in summer and heat loss in winter. The walls are improved by decreasing the thicknesses of poured concrete to a quarter and uses a facing material, whereas the core will be reinforced CMUs insulated with high-density polyester foam and finished with mortar and sandstone. The windows would be double glazed and the inner layer filled with argon gas because it has a high conductance level. The roof is covered with thin metal sheets to reflect radiation on bounded bitumen on roof screed on concrete. All the insulation is towards the external due to the amount of heat gain during the summer, which is more significant than the heat loss in winter. Even though Tehran on average has a sky coverage of 45%, there is yet a good amount of radiation emitted onto the surfaces that can be captured for harvesting solar energy. Tehran has a solar irradiance of 6.35 kilowatts per hour. The best location to install the PV panels is on the roof of the galleries with a tilt of 30 degrees towards the south. That has a total area of 72 square meters. In this 72 square meters, 43 panels can be laid, which will result in an output of 3,650 megawatts per hour for a specific model of LG PV panels for every gallery space. The panels are 94% efficient with 70% battery efficiency. The existing building has two indirect skylights serving the galleries and four major skylights in the foyer serving the ground level and the basement, which is accessible through a circular ramp. According to a table of universally accepted percentages of natural lighting for spaces, it has been mentioned that museums and galleries need a source of natural light between 2 to 5% only. As mentioned in the previous strategy, which was to improve the insulation of surfaces, changing the type of glazing by itself had a significant impact on the amount of light entering into the space, according to the calculations simulated by Ecotech. However, there were still areas that needed improvement, and in order to further improve the light qualities, the degree of the window openings had to be decreased by 35% until the spaces had the ideal amount of natural light. Researchers from University of Esfahan have concluded that the ozone level is affected directly by the meteorological conditions such as the air temperature, relative humidity, solar radiation, wind speed, and wind direction. The causes of the rising air pollution is mainly a byproduct of motor traffic, especially when diesel is used for cars rather than petrol, and the burning of fuels from the power plants. Ozone is a specific type of a pollutant which does not get absorbed to the sky, but it stays at ground level and causes severe illnesses. The museum at certain galleries overlooks the main street, where it is always heavily congested with traffic, therefore having an opportunity to test it to react against direct pollutants. A hospital project in New Mexico utilized a specific, largely perforated tile for the facade to absorb the air pollution passing from the surrounding streets. The tiles are manufactured and patented under the name of ProSolve 370E, where each unit is coated with titanium dioxide and smog-eating technology that is sunlit activated. The chemical reaction, which takes place once UV rays hits the surfaces, results in a least possible amount of CO2 and water, especially when there is humidity. The tiles perform more efficiently when placed directly in front of the source of the air pollution. The tiles are already designed to have the highest amount of surface area. However, the design can be altered to look more subtle in terms of visual dominancy. There are always better strategies to choose from other than the ones we finally deliver in our designs. To study this project as a precedent study was quite challenging because the architect, prior to the construction phase, had worked out the site and climatic issues to a level where it does not conflict his concept of the project and the final outcome. However, one must take into consideration that the project was constructed during the early 70s, and the population has grown ever since, and so did the traffic and air pollution. Also, interestingly enough, during the past 32 years, since the Islamic Revolution in Iran, the type of clothing has changed, which has a direct relationship to how people feel about a space. Clo values is one of the factors where not many consider, but in this specific project, it is interesting to recognize, especially when one has personally experienced the before and after of the museum. As an architect of the 21st century, we hold a great burden of responsibility regarding the way we impact the Earth. Every decision we make can either make or break planet Earth. 40 years ago, not much consideration was done regarding the performance or energy efficiency of a building, but our era demands it with all its will.